Yeah, so hello everybody. Thanks for having me on for the meetup. And yeah, so a little bit about me. I am work on machine learning tools at Roboflow, which is a computer vision startup. We started about 2 years ago. The co-founders and I are from Des Moines. And so that's kind of unique. But we were kind of thrown into the world of AI and like VC-backed startups through the YC program. We did YC 2 summers ago, and then have since gone on to raise a seed round and a Series A. So our Series A venture-backed startup, kind of scaling a web-scaled computer vision platform that's predominantly a dev tool. And so today I kind of just wanted to like sort of just talk about developer tools, SaaS products, how those might work with machine learning solutions, a little bit about computer vision in particular, and then we can kind of zone in from there with all those things put together into kind of like the landscape of computer vision dev tools is what I'm kind of going to be shooting for. But also, I kind of want to just like hear people's questions along the way and see where the conversation takes us. I think this is kind of a cool, a little bit of like a roundtable-esque forum too. So I want to just dive into whatever piece we all get interested in. So are you guys all able to see my screen here with the presentation?
Yep, I think so.
Yes. Yep. Yeah, cool. So just starting off, I wanted to just start off with these kind of like topic areas. So the first one is what is a dev tool? So in my mind, a dev tool is any kind of software that a developer can use to speed up the rate at which they're developing something. That developer might be someone who's actually programming, and usually it's like a programmer utilizing something. So for a lot of us, even like something as raw as a programming language itself is a developer tool. And then a lot of these developer tools also have web front ends too, which a lot of the highly scalable ones are kind of predominantly built on that. And they kind of, like I said, allow developers to pick up, stand on the shoulders of giants and abstract things away, usually through the form of like API calls and stuff, where you can just be kind of integrating someone else's software into yours. So one of the like famous dev tool example companies is Twilio, which allows you to just send text messages and SMS just by making like a simple post request at their servers, and then you pay them by API call. And so a business that's based on just raw API calls is probably the most kind of like pure form of dev tool in my mind. Roboflow isn't quite there. We'll kind of get into a little bit more of our business model as I talk about things. But yeah, that's kind of the general idea of a dev tool. And then the other side of things is software as a service, which is something else that Roboflow does, since we're more like a platform based, which is more like your kind of like traditional, like if your company buys like HR software or something where, you know, there's some UI that you utilize to accomplish something, and then it's billed on a recurring basis, and it's like a B2B business. So Roboflow slots in somewhere in between those two things, where we're our target audience is developers, but we kind of have sort of a SaaS solution on top of it that ends up getting sold. And we're trying to get more and more into the API call based business. And like we have some of those APIs that people are drawing from, but we've sort of found that SaaS tends to be the thing that sells a little bit better for us, at least. And I know it's different based on, you know, based on what business you're working on and all that kind of stuff. Yeah, and then so zoning in a little bit further, I have what are machine learning dev tools. So these are dev tools that are focused at developers that allow them to speed up a machine learning workflow. So they might be, there's one axis, which is like your level of machine learning expertise. And then the other axis is just kind of like, well, so that's kind of the main axis of these dev tools. Is some are marketed at AI scientists and experts who are doing research in the field, and your number one customer would be like OpenAI, say. And then the other range would be people who are just trying to find, I mean, the other far side would be just a no-code application that anybody could use. And then Roboflow is kind of somewhere a little bit in the middle, to the left, to the less knowledge side of a developer who might have an idea for an app and just wants to integrate a machine learning solution, but doesn't necessarily want to go off and learn PyTorch or TensorFlow or learn how to deploy their own neural network frameworks. So they can just kind of pick up you know, a lot of these abstractions and then then they can wrap those abstractions with the code that they are working on developing. Yeah, and then the state of dev tools and computer vision is going to be further down when I talk a little bit more about the computer vision pipeline. So I'm going to pause there and kind of see if there's any questions, and just feel free to write in the chat or say it out loud too. And if there's any questions from there, we could dive into them.
Anybody have any questions to begin with here? All right. So
Okay.
you can roll on.
Yeah, all right, I'll just go ahead and just roll right on then. Yeah, so just going into computer vision a little bit, as I had a couple of examples here that I wanted to show in case in case the computer vision part of this talk is like completely new to you. So there's been, over the years, more and more techniques have been developed in the machine learning world to process images. And the way that this works is that algorithms have been designed to split an image into just kind of its raw pixel data, and then process that data by forming features that are more intelligible to a machine learning algorithm that will eventually make a prediction. So in this picture, we can see here, there's the number 8 that's getting split into a number of pixels, and then those pixels are fed through layers of a neural network to do calculations to then eventually make a prediction at the end. And here I've got a kind of a cool demo. This demo I think is really cool, even if you're like super familiar with machine learning. I'll post in the chat here. But this, here, where's the chat? This is a demo of training a convolutional neural network on MNIST, which is kind of like a classic hello world computer vision example where you're tasked with classifying the numbers 0 through 9. And so when you start this, you can kind of see the network is learning from a data set. So it has a data set of these examples that's being shown, all these things, and then it's splitting it into, you know, the various pixels that it represents, and then paying attention to certain ones. And in the activations, you can see which pixels the network is starting to learn to pay more attention to. So we see for the different numbers, it's kind of able to start to pick out the most relevant features to look at. And then, yeah, eventually you start to see, after you train your model, that is, after you show it many versions of examples, it starts to generalize, and it can make predictions on data it hasn't seen. That's the validation accuracy. And that's kind of representative of, okay, now if I was going to take this out into the wild, you know, and get out of the experimental world where I'm running this training in my web browser, then that's how it would perform. But what I think is kind of nuts about this is I think the Git commit on this is like 2016 or something. And so Carpathia was already training, like already doing like web scale machine learning, like way before the rest of us were. But it's not too late. It's not too late. If our company's success is any evidence, then you can start after things have been things have been proven out a little bit more. But yeah, that's pretty cool. Pretty cool example. And then other. Oh yeah.
I was just going to ask Jacob. I mean, in that particular case, it's all been labeled and tagged, right? So that you have this MNIST set that has, I don't even know how many thousands and thousands of characters, right? That have then been tagged. Said, hey, this is a 3, this is a 2.
Yep. Yeah, that's right. Yeah. Which is a key part of most of these computer vision learning cycles is that they're supervised. So you need to be providing data labels along with the images that you're showing them, or if you're doing NLP, you're showing them text with labels, and ASR, you're showing them waves with labels and stuff like that. That's all supervised learning. There's exciting stuff that has been happening in the AI world with these unsupervised techniques, which are more or less just continuing to provide better and better base models to be fine tuning from. There are some zero shot scenarios where you can actually do just no training. Like for example, now if I wanted to pick out a model to identify with 100% accuracy what these digits are, I could probably use a zero shot approach now where I don't have to train. Those are some of the models that are kind of scary and kind of awesome. Actually, let's dive into one of these live. There's this one that just came out from Facebook AI Research, where it can just do object detection and semantic segmentation, where it pulls out objects from a zero shot. So here, the crazy thing about this too is you can provide your own vocabulary. But yeah, we can see here that this is like not any training. You could just have put your list of whatever you wanted in here. I don't think they have that here on this API, but I spun this one up, spun an API up for this one recently. We're going to start using this for some of our zero shot labeling, where you can just say the things that you want and boom, you already got it. But the fact of the matter is here, as opposed to the model we saw training, is the training is going to be a lot better if you're going into like a specific scenario. So I think it was maybe Pete who was talking about the defect detection. Those defects probably are like unique to a certain kind of object, and they need a specific training routine that a general model won't get as quick.
That was me.
Yeah, nice. Yeah.
So back in 2016, you think they had labeled, there must have been a lot of data to build this up even back then, right?
Oh, for the MNIST dataset?
Yeah, just looking back at that.
Yeah, I actually don't know the history of that, but I'm sure there was probably some academic dataset gathering. And there are, there are landmark supervised datasets, which I think are kind of interesting to look at, like Microsoft Cocoa, which is just common objects in context. So this is a data set for object detection. And they just have like common things like stop sign, for example. And these are labeled with object detection and semantic masks. But there's all these kind of like these data sets that that academia has built up over the years to be kind of showing both benchmarking research, but also providing, some good data that you can train on as well.
Awesome. Yeah, thank goodness to people that have sat there and tagged and labeled all that stuff.
Yeah, we should be thankful for that. I have something cool to show on that front too. Actually, I'll just show it right now. But so actually, it feeds into my next slide pretty well. So on Roboflow, we've had a pretty hefty level of usage that we've been finding that people are kind of using the app for all sorts of different tasks and different range of computer vision tasks. And so I listed a few of those here where people are doing anything from, we have maybe like 10 or 12 users all working on like fish measuring, where they have models running underwater. And then anything from that to industrial cases like conveyor belts and you know, different things. There's like augmented reality stuff with like board games and all sorts of things, esoteric things like sushi identifier or things like that, or like checkout. But you can also do this on other types of imagery like satellites. Roboflow is now on the space station, which is kind of a cool thing that happened to us recently, on the International Space Station. But yeah, but so one cool thing is, as Justin mentioned, part of our app is public, and so that means that there's a lot of the bulk of our users are students and hobbyists, and we've been working on starting to expose those as a free version, so you can get labeled data sets just like right on here. So if you needed to have a dreidel model, for example, I don't know if anyone in the audience tonight is Jewish, but yeah, all that stuff is starting to become more exposed. We don't quite have like a full fire hose on this yet, but it's coming. It is coming, and it's going to be semantically searchable. So you can get as many data sets as you could ever want. This is a cool one. This is one of my favorite ones. Hand sign language. But yeah, so that's a detour into data sets. But yeah.
It's cool. I think I saw something related to the sign language thing where they were integrating it into Microsoft Teams or Zoom or something like that, where people could be signing and then it actually was recognizing that and putting it into text. Very, very powerful.
Oh, that's really cool. That's really cool. Yeah, that one that we were seeing was like just a single frame or something. But if it's Zoom, I don't know if it's a Zoom product or something, or Microsoft product or something, they probably have like some sequential model running underneath to decode the sequence and stuff. Because there are certain ones, you know, where you like would move it, like I think a J is something like this, where you'd need to have you can just do it frame by frame. You need the video sequence.
Yeah. I don't know if it was a startup or whatever it was, but that's what they were doing. They were literally working on, you know, basically as it was video sign, and it actually was writing it all out in text, which is phenomenal.
Yeah.
I think I've seen that with Google Teachable Machine before.
Okay.
Nice. Yeah. Okay. So just chugging along here. So we kind of have the computer vision workflow broken out into this series of steps that we think is replicatable across pretty much every computer vision task that people are trying to do today. And I think this is also true for pretty much any AI model that people are deploying in production today. That is, the first step is to collect data. So they're going out and they're gathering a data set that is representative of the domain that they're applying to. So they're presumably domain experts in some sort of way. They know what measurement of fish they want to be tracking. They know what kind of fish those are. They know how to get images of them. And they kind of know what they're after. So that collection step is always domain dependent. And then organizing. This is where you're taking your data, you're figuring out which pieces of it you want to include in your data set, which ones you don't. You're organizing it into train, validation, and test splits. This is the training images are the ones that you'll show particularly to your model, and then the validation set is where you'll be seeing how well your model is learning along the way. And then the test set is where you're it's the final boss, where you're seeing just, how well your model might perform in the wild on representative test cases. So kind of that organization process there's a labeling step where you actually need to be making these annotations. And in Roboflow, that's predominantly just drawing boxes is what most people use it for. But we do have some other labeling types like classification, and then segmentation is coming soon, where you actually draw just like a little masked outline around the object. In the NLP world, this could be anything like classifying text or doing like a slot extraction. We're taking apart different pieces of the sentence, or maybe you're completing sentences, or you're synthesizing, or whatever thing that you're trying to do is a similar process. You need to label it, unless you're using one of these zero-shot solutions that I was talking about in the beginning, but those are usually not going to be good enough for your custom domain. And the next step is processing. So this is maybe an arbitrary step, but Roboflow does a lot of this, which is we do a lot of like image processing, where we'll help you like resize your images, or we'll help you make little augmentations where you could tilt them a little bit, or zoom in and out a little bit to simulate variations in your data, so you can label less data. You can use augmentations to increase the size of your training set. And then we package that into a version. So then you have some data set version, some little fixed packet of data that you're going to use for training, and then you pass that on to training. And this is the part where sometimes people get like they might not know it as much. So this part, we have a one-click training solution where you can just kind of like send your data set onto one of our GPUs in the cloud, and then it does your training and then spits out your model for you. And that's AutoML is what the train solution is. But we also let people go off and train on their own, and there's all kinds of different ways that you can model things. So we have this this page for anyone who's curious. You can get on here on models.roboflow.com and see example notebooks of how to train different state-of-the-art computer vision architectures. So actually, I assume we got a pretty technical audience here. Let's jump right through one of these. These usually start off with like, so this is Google Colab, where you can get free GPUs. It's free cloud GPUs on a Jupyter notebook. Great for learning and experimenting and trying things out. So usually there's some installation steps. Here we're showing, here we've got a GPU that we're training on, and then conditional on that GPU, there's different things we set up. We install some stuff. This is Darknet, which is an infamous C framework that object detection started in by this guy, PJ Reedy, also known as Joseph Redman, who started the YOLO models. So he's famous for that. Then he's also famous for quitting vision because of what the military was going to do with it. So my opinion on that is I think the cat's already out of the bag, and there's all these other use cases, and I haven't done anything with the military yet, so I'm gonna probably keep it that way, but we'll see. I don't think they would trust my dark APIs enough to hire me anyways. But yeah, then the next step, you just get the data. And so this Roboflow lets you export your data with a pip package, with a Python package. And then you have some data set, and these are images, and then their corresponding label file is a text file. Some data parsing in this section, nothing great. But then here we can kind of see what a network might look like in code. In Darknet, it's funny that I picked the Darknet one because this is like the most obscure one. But this one you can define your neural network layers, and you can also just take this as just like a fixed thing, which is pretty much what I do most of the time. And then you train it. So while you're training it, it starts learning from your data, and you see the loss going down. And this is the same thing we're seeing on that like Carpathy demo, where loss was converging as more and more data was getting shown to the network. And then afterwards, you can run inference, where you reinstantiate the neural network, and then you can make a prediction. So here we saw that in this notebook, I didn't actually execute these cells, but just with the data set of blood cells, we're able to teach the model to identify the difference between red and white blood cells, which is kind of cool. I think this was a data set only of like 300 images too. So it shows you that even with a lean data set, you can start to be making some pretty good progress just with the labeling. But like I said, Roboflow also has this thing abstracted. So it's all just kind of a one-click training solution. And yeah, and then the next step is deploy step, which is where you take that model, you put it somewhere, and you run inference on it. So at the end of the day, you're shooting for something that's gonna run, you know, in the environment where you want it. So people will sometimes be taking Envision. So Envision, it's very the main difference than NLP is that a lot of people are deploying this on the edge because they need real-time inference, where they have like a robot or some process that needs the inference latency to be a certain level. And so that means they're using smaller neural nets, they're optimizing them, they're buying edge hardware, and they're kind of trying to push things down to the embedded level. And then in NLP, a lot of stuff is just happening on the cloud. So you can just pay for inference because it's not that expensive usually to just run a single pass through a neural network. But we also have that too. Some people just need cloud inference, and so you can infer on your model kind of wherever you want. So that's deploy. And then display is kind of like another arbitrary step, but this is one where you're integrating this into an app and you're going to do something with it. And that's hooking it in to wherever you're going. And so I think one of Roboflow's biggest, one of our best epiphanies that we've had is that if you, when you get to this step, this should be the step that takes up 80%, 90% of the time. And we recognize that. So we really like working with really talented developers who are headed somewhere. And this is just a small piece of a larger app where they're doing a lot of other stuff. And I think that's kind of the right way to think about AI these days. It's not some general sweep all solution that you're going to have, but it's going to be something that enhances a process or maybe enables a software process that was previously couldn't have been enabled. So yeah, so that's kind of the computer vision workflow steps. I don't know if there's any questions on that. As a next step, I'll probably go on and talk a little bit about different companies and different parts of the stack.
Yeah, I got a couple questions, Jacob, and anyone else, please feel free to jump in. I was looking at the data sets and stuff like that as you were sort of running them out in Google Colab. Are you pulling in from public data sets, or do you guys have some of your own data sets that you built up?
Yeah, so there's that universe.roboflow.com
Yeah.
thing that I showed where you can get data sets. How can I get the data set? Download, yeah. So you can get data sets from there, or you can make them in the Roboflow app itself from just raw images to make your labels in there and stuff.
I see. Okay. Yeah, I wasn't sure if you guys had created, like if you had spent time labeling and creating your own data sets, or are most of these like we need to provide the data set, or it's a publicly available data set like MNIST?
Right. Yeah. Most of the time you bring your own data set to Roboflow, or most users are. But the thing that we're starting to, the theory that we have is that there's like some of these where, you know, it overlaps, you know, so people could, just like GitHub repos, we think people might be like kind of working on and collaborating on their data sets up here. So we'll see if that happens, then our unicorn story can work out, but otherwise we might just be another SaaS business out there. So we'll see.
Sure. But yeah, you want to create this ecosystem, right? Of all these sets that people have done.
Yeah. And then ultimately, you know, it'd be cool. You can infer against this. I actually have no caps on these now. So don't send too many API requests. I mean, beyond just like the number of servers that I spin up will at some point stop. But you know, there could be an API based business on just, you know, collecting these inferences and facilitating that.
Sure. Yeah, and that leads to my next question. Like, you guys are providing the API to then run these inferences on, right? So we can train it. Could we download the model and run it on any hardware we wanted, at the edge? But we could also keep it in your cloud and run calls against it. Is that kind of how you guys provide it?
Yep. Yeah,
Okay.
exactly. Yeah. So, yeah, when you have a trained model, you can either keep it and run inference in the cloud or get it out and put it on your Jetson or your whatever hardware device you have down wherever you are.
Sure. Or run it in
And
your own
obviously
cloud.
that the devil's in the details there, right? So we say, we promise X kind of deploy, and then there's some dependency that breaks, and I'm down there in the weeds and stuff with somebody, but that's just kind of how deploy goes.
Sure.
Uh,
But if I'm running like TensorFlow Lite or something like that, is that something that you guys would then allow me to export a TensorFlow model?
We don't have that yet,
Okay.
but that's the idea. So it's funny that you're asking these questions. So we have a deploy solution where we actually deliver Dockers
I see.
that have the
Okay.
installs, and then the Dockers will pull down your weights and then spin up and kind of serve the service, just like the hosted API does. It just is kind of like a version of the hosted API on your local server. But these have been notoriously over complex. The reason we do it is to track device usage to see, if we can scale the business scale the cost based on the number of devices that are deployed to.
Sure.
As opposed to a raw weights export, which will be easier, especially for a developer to use, because they can just take those weights and then start integrating them immediately into a script that runs. But then we don't know, you could take that and you could deliver that model to 10,000 devices and we would never know.
Right.
So
Exactly.
I've been pushing towards just the weight export. Actually, I've been the kind of lead developer on deploy predominantly, but I've been kind of starting to say, like, I think it's easier to do these weight exports and try to have the software cost be the lever of things. But that's an internal battle that I might not ever win. And I also know Joe and Brad are pretty smart, so I trust them on that too. So
Sure. No, I see advantages to both ways, but yeah, so you get this Docker container and then you basically run it at the edge in Docker, which is pretty universal anyways too, as well, right? As an end developer, you can run Docker pretty much anywhere. So I can see both sides of it, but that's really flexible, I guess. It's kind of cool. I can take this Docker container. I could even run this Docker in the cloud. So you're saying I could run it anywhere.
yep.
Yeah.
Totally.
Awesome.
How am I doing on time? Are we at the point?
Oh, we're doing
where-
good. Yep. We're great. You want to?
Should I keep talking a little bit?
Yeah. Please. Plenty of time.
Okay. Okay. Yeah. So going a little bit in, I guess now we could talk about different solutions at each kind of like level of the stack. So for collection, obviously there's kind of you can kind of do anything here. The number one thing is you should be like collecting from the device that's going to be capturing the images from the camera that's going to be capturing the images that you're inferring on. But yeah, there's all those data sets that I was talking about, and then there's one platform out there called Aquarium Learn that lets you kind of like explore the semantic space of your data to kind of think about what you're collecting. I guess maybe that's a little bit in the organizing step. And then there's a company called Clarify that we compete with, that they have a solution in here called Clarify Spacetime, which is similar, where there's like kind of like search and stuff like that, and you can be interrogating your data and jumping around. There's a app called Voxel 51, which is a pip package that lets you visualize your computer vision data set, which is also kind of pretty similar to us. And machine learning engineers in particular like that one a little bit better, because they're native like pip package users anyways. And then in this like labeling process, there's all kinds of labeling providers. There's different web platforms for it. In computer vision in particular, there's one called Supervisely, one called Labelbox, and those are kind of like good web UIs. Roboflow is as well to do annotation labeling. And then you can also farm this out. So there's services like Amazon Mechanical Turk, and then there's a big company, one of the biggest AI company, which is Scale AI, and they're all based on just helping people annotate huge data sets. And to do so, you need a big crowd of annotation workers, and you need to be able to coordinate. And then also maybe you have the model learning a bit along the way and kind of helping inform the annotation workers and stuff. So there's a lot of solutions in that space in particular. And in the processing thing, there's some open source things like Albinations, which lets you do augmentations with, or I think it's Albinations, I think is what it's called. But yeah, there's open source solutions along the way here too at every step. And then in training, there's some of the big cloud services have big like training pipelines that you can use, like Google AutoML Vision or Amazon Recognition. And these are different kind of AutoML pipelines where if you already have a labeled data set, you can just kind of give it to them and they'll give you a lot better model than I will, but my software is easier to use. But yeah, there's probably like a huge team of PhDs that are working on some of these AutoML solutions, and they're just doing training and maybe a little bit of deploy. And then in deploy, there's all these hardware companies and different deployment frameworks like TensorRT and Onyx and OpenVINO and all kinds of different like deploy languages and representations, and there's just all sorts of stuff on that side of things. And then there's also some of these like device monitoring systems now that are starting to come out where they're just particularly focused on letting you deploy your models across a wide swath of devices and stuff like that. So definitely an area where there's stuff going on too. And so you might be thinking, like, this is a pretty competitive space. What are you guys trying to do? So our unique proposition is that we're just fully end-to-end. So we do everything, and you can kind of stay in one streamlined flow. So when you want to go to update your model, you can keep going around this circle again and again with an active learning loop is kind of what we're shooting for. And then, yeah, the other side is too that we just integrate with everything. So if someone does this better than us and our customer wants to do that, we'll just hook in our part at one of those flows. We'll support their annotations or something like that. So that's kind of how we've been seeing that part of the competitive landscape and computer vision dev tools, I guess.
Nice. You mentioned loop. I was just wondering if there's, and also I was just thinking about Mechanical Turk. So, I mean, so somebody brings something and they like I have a bunch of images and I want to have them trained, but then if I want to have sort of this human in the loop, right, with regards to, hey, here's there's errors and stuff that are happening in my stuff. You guys provide the tools then for the human to come in and update it. Is that true?
Right. Yeah. So you can load in new images and label new images and then update the model and version things. So that's a little bit what I had up here on one of these data sets. But just a series of versions as you're working along and creating new versions of your model.
Sure. Yeah, I know there are some companies that actually provide the human in the loop resources.
Oh, right. Yeah. So that part we wouldn't. And the reason being there is we could integrate with a provider that you find on that front, and then also we more or less are going to try to convince you to care about your data set and label it yourself, and keep iterating, and whoever the engineer is who's deploying the model should be as close to the data as possible.
I see. Yeah, no, that makes sense. So it's sort of a one-stop shop for all of this stuff going as it's going through this entire pipeline.
Mm-hmm.
That's awesome.
Yeah, seeing a couple things in the chat. Yeah, label box, definitely a really cool solution. Definitely in our space. And same thing, yeah, where they have like a pretty good active learning loop that you can kind of be following as you're refining your model. But something we're going for as well. And then I see one, does Roboflow offer bias detection algorithms or resources to connect with external tools? We do not. But and then that's kind of an area that I actually don't know a ton about, so I might not have the best answers on where to point you. Usually I have some GitHub repo or something I can pull out, but I don't have a good answer for that one. I don't know if anyone else in the group maybe has worked on that or has some ideas. Yeah, and then moving on to the next one. Does the high price of GPUs limit how much you can grow? Which is true. We have a lot of GPU costs. The interesting thing is we're on the tail end of our AWS credits that we got when we did YC. So we've been pretty much just burning GPUs, but I don't know. Things train pretty fast now, and one train on Roboflow might be like 50 cents or $1 or something. So we're I mean, what else is venture money for than spinning GPUs, right? That's kind of my approach, which is then just and I'm pushing something into prod on Monday, I think, that's going to let everybody, all public users and everybody to train for free. Right now we let you do it, but you kind of need to reach out or something. So I'm excited about getting some more GPUs going.
So Jacob, can you just ask my question instead of writing it? Okay,
Yeah.
cool. So can you actually share your screen and go back to that, like the Python code that you showed with the neural network kind of configuration?
Mm-hmm.
So if I understand correctly, that configuration essentially enables the end user, the one like a business that is actually training the model, to have a say in their model. So is it fair to summarize the value proposition of Roboflow as basically enabling businesses to get, basically focus on the essential parts of their computer vision algorithm instead of like the infrastructure for training and, actually running it, deploying it?
Totally.
Okay,
Totally.
cool.
And especially in the beginning of days, our kind of like pitch was we're going to write the boilerplate computer vision code so you don't have to.
Okay, that makes sense. And
we
yeah,
provide
it's
tutorials on
very mundane, right?
how to
Cool.
convert into the right data set format for whatever network and stuff. And so this collab, though, I will say this is if you want to export your data and go on your own training, and you can work on specifying that and creating that part of your process. But we also have the one where you don't even see any of this stuff, and you just kind of click a button, and this sort of stuff kicks off on the back end.
Okay. So about this configuration file, though, is this like a standard configuration?
Yeah, no, that's
or is it your? Okay.
Yeah, this is, I gave a weird example that's in this darknet framework. And this is just how you specify it in darknet, but usually people are running like PyTorch, which I'll try to pull something up just to even for the aesthetics of the code. Let's see, SageMaker. Oh, this is also cool. If anybody's interested in this. They introduced Google Colab competitor at AWS. So if you want free GPU to be working on stuff on, oh, whoops, I want to do GPU there. You can get on here and you can fire one up too. I might have, I'll find a better one. YOLO v5 is a really cool repo. If anyone is interested in kind of diving more into the code, but I'll just show what this code usually looks like. It's usually this kind of like PyTorch code, which is sort of is, which is just like the popular way to define neural networks, where you are passing matrix data and running calculations and stuff. And this is maybe kind of hard to read PyTorch because it's like more of like a state-of-the-art repo, but this is the kind of code that people are usually writing.
So if I have already like done the work of creating a PyTorch like algorithm, yeah, describing my model using PyTorch with this kind of format, then what would it take for me to use Roboflow? Or basically, do I need to write that configuration or translate my logic into that configuration file?
Yeah, yeah. So for example, if you wanted to use this model, you can export from Roboflow in the correct dataset format, and then follow kind of like a tutorial on where to, how that data can flow through this. Or you can go off and like kind of completely create your own flows. And we're just kind of like, just take your data and go off on your own adventures, So that's the other thing. So we have varying levels of like
Okay.
ways that you can use it.
All right, sounds cool. Thanks.
Yeah. Were there any other questions? Nice. I guess I had maybe just one other thing to share was this is my email. I'm Jacob at roboflow.com, and I work at Uptown WeWork. So if you're ever in the area, drop by and let me know. Super excited to talk about this kind of stuff. And we'll hopefully be coming to more of these meetups. Oh, and the other cool thing about this, if you're looking for a job, this is coming up on my team. Full stack machine learning engineer, someone who's maybe like has experience with machine learning and the cloud and different maybe like web frameworks, is a position we'll be posting. So that'll be on our newsletter. And you could also always just email me and I'll make sure to add your profile for it. So it's remote, but obviously I'm excited about Minneapolis and super excited about Minneapolis machine learning in particular.
Yeah, for sure. How many people are in the WeWork office down there?
So for Roboflow, it's just me and Lucas. And we're a company of like 25 people or so now. So
Nice.
but we're the only ones who are in person too. So that's kind of another bizarre part about it.
Well, that's good. That's good. No, that's living right in that startup world here, and around 25 people. That's a fun place to be. So sounds like you guys are building some pretty cool tech. And you were one of the early people, right? Is that true, Jacob?
Yep. Yeah. So I was first hire, and I've been kind of, just driving a lot of the dev work along the way. And I do a lot of content and YouTube stuff too, stuff like this. That's kind of like what a big part of it is, just getting the stuff you wrote out into the world. Yeah, Fishman knows what I'm talking about.
For sure. I dropped a link to this Label Studio, in there. I don't know if you've heard of that as well.
Oh no, I haven't.
Oh yeah, it's labelstud.io. So they've kind of been a little fun with the top level domain, but it's an open source data labeling tool. So one thing I thought was kind of interesting was, it's actually an open source, like you can run it on your own hardware. They have a GitHub repository, and again, it's a way to label data, but I thought it was interesting that it was actually an open source project. Are you guys using a fair amount of open source tools, or are you guys building everything internally?
Oh yeah, totally. Apache 2.0 is my favorite thing to find. But yeah, no, Roboflow is a big amalgamation of open source technology, basically.
Good to hear, for sure.
This was super insightful. Thanks, Jacob.
Yeah. No, thank you all for coming out and everything. I had a great time and looking forward to the next one too.